All right, let's talk about a tool you've probably got lying in a drawer somewhere, the electric screwdriver. It seems so simple, right? But its story is this incredible journey through physics, chemistry, and just sheer human ingenuity that literally changed how we build our world.
And I'm not exaggerating one bit. This tool really did change the world. Think about it. From giant factory assembly lines all the way down to the flat pack furniture in your living room, the power to drive a screw without getting tired has completely revolutionized how we make, well, everything.
Because that's the real story here. It's not just about slapping a motor on a stick. It's about how this simple hand tool went from being pure muscle to a device that has, for all intents and purposes, a brain. To really get just how revolutionary this thing is, we have to go back, way back to a time before electricity, to a world that was powered entirely by us. Welcome to the age of muscle. For almost 500 years, the screwdriver pretty much stayed the same. I mean, look at this timeline. From the time it first showed up in the 1400s, right through the golden age of craftsmanship, it was just a piece of steel with a handle. Every single turn was powered by human effort, and that power had a hard limit. So here's the bottom line. The whole system had a fundamental bottleneck: the human body. Your power came from your arm, your speed from your wrist, and your accuracy from pure skill. The real enemy, the problem that had to be solved, was just plain physical fatigue. There had to be a better way. And that better way, of course, arrived with a spark. In the next act of our story, electricity lends a hand. And it wasn't just for light bulbs, it was about to give our tools superhuman strength and finally solve that nagging problem of fatigue. As factories and workshops started getting wired up, the first tool to really get a power-up was the drill. From there, it was a pretty obvious next step to adapt that spinning motor for a screwdriver. And sure enough, by the 1920s, the first corded models started showing up, and they completely changed the game. Now, the physics inside these early tools was simple, but absolutely brilliant. At the heart of it was a brush DC motor. So as you can see here, electricity flows through these little carbon brushes into copper coils, which creates a temporary magnet. That electromagnet gets pushed and pulled by other magnets around it. That's the Lorentz force in action, and that forces the whole thing to spin. In a nutshell, you're turning electricity into motion. But there was a catch. That motor spun way, way too fast. To make it useful, engineers had to use gearboxes to slow it down, which had the awesome side effect of cranking up the rotational force, or what we call torque. It's a classic trade-off. If you want that powerful twisting force to drive a screw deep into wood, you gotta give up some of that raw speed. But this new power came with a whole new set of problems. These first tools were heavy, they were loud, and most importantly, they were stuck on a leash to the wall. So yeah, they solved the fatigue problem, but they created a brand new one, a complete lack of mobility. And that brings us to the next great chapter in this story, the mission to finally cut that cord. The goal was simple, but so ambitious. Take the power of the wall socket and somehow cram it right inside the tool itself. You know, the first attempts back in the 80s and 90s used batteries like nickel-cadmium and nickel-metal hydride. And sure, they worked, technically, but they were far from perfect. Those old NiCad batteries had that annoying memory effect. If you didn't drain them completely, they'd sort of forget how to fully charge again. Plus, both types were heavy and just didn't last very long. The cordless dream was still kind of a clumsy compromise. And then, in the 2000s, everything changed. Lithium-ion technology, yep, the exact same tech that's in your smartphone, finally made its way to power tools. And it wasn't just an improvement, it was a total game changer. The reason lithium-ion was such a massive breakthrough is pretty clear. These batteries pack way more punch into a much lighter package. That's what we mean by high energy density. On top of that, there's no memory effect. They charge way faster, and they hold that charge for longer. This was the tech that finally made powerful, lightweight, cordless tools a real thing. Okay, so we've solved fatigue, and we've solved mobility. What's next? Well, the next frontier was intelligence. How do you make a tool that isn't just strong and free, but also smart? While the first step was a major motor upgrade, those old brushed motors wasted a ton of energy as heat and friction because the brushes were physically rubbing and wearing down. But the new brushless motors, they use smart electronics and magnets to spin. That means way less friction, less heat, and a huge boost in efficiency. More of your battery's juice goes directly into turning the screw. And this is where it all comes together.
A modern screwdriver isn't just a motor anymore. It's a computer with a motor attached. It has an electronic control unit, an ECU, that acts as the brain. It's constantly talking to the brushless motor, controlling the torque with incredible precision, and it even has a system to monitor the battery's health so you don't damage it.
One of the coolest tricks this little brain uses is something called pulse width modulation, or PWM. So instead of a steady flow of power, the ECU fires off these incredibly fast pulses of electricity to the motor. By changing how long each pulse is, the width, it can control the speed and torque with pinpoint accuracy. It's a level of control you could never, ever get from a simple on-off switch. This table really puts it all in perspective. Just look at the difference. We've gone from a heavy, corded tool with a dumb switch to a lightweight, cordless, computer-controlled device that's smart enough to stop itself before it strips a screw. I mean, that is an incredible leap from a brute force machine to a genuine precision instrument. And believe it or not, the story isn't over. Not by a long shot. Now we get to look at what's next, as engineers are already working on the screwdrivers of tomorrow, solving problems we're only just starting to think about. Seriously, imagine a screwdriver with AI that can literally feel the material it's going into and adjust its own torque on the fly. Or one that connects to your phone so you can track its performance on a job site. With things like solid-state batteries and more sustainable materials on the horizon, this tool is only going to get smarter, safer, and more efficient. When you really look back on it, the whole journey of this humble tool breaks down into 3 simple, revolutionary steps. First, electricity gave it superhuman strength and solved the problem of fatigue. Then, batteries came along and cut the cord, giving it the freedom to go absolutely anywhere. And finally, tiny computer chips gave it a brain, transforming it from a simple machine into a smart, reliable partner. It really makes you wonder, if a simple screwdriver can have this incredible evolution from muscle to machine to, well, mind, what other everyday object that we take for granted is about to have its own revolution?